Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to talk about integer operations. And before we do so, we must realize that when numbers and or variables are being combined via positive or negative signs, okay? So in other words, when we see them being added or subtracted, okay, they are always really being added. Okay, we're going to explain that in a little bit. Therefore, there are some rules which allow you to use the negative sign correctly. And before we go over those rules, let's just do a real quick refresher on absolute value. Please let's remember that absolute value is the distance from zero. The absolute value is always positive since it is a distance and is represented by this symbol right here that I am circling in red. Okay, so let's talk a little bit. The rules for adding and subtracting integers. Okay, we're really only adding them, and I'm going to explain to you how that works right now. Rule 1, when the signs are the same, simply add the given values and keep the same sign. When the signs are the same, add and keep the same sign. For example, 4 plus 7. Well, 4 has a sign that is positive. How do you know? Because there's nothing in front of it. If you don't see a negative in front of the number, then it is positive. So I have 4 plus 7. They're both positive. When the signs are the same, you add and keep the sign. So we're looking at 11. Now, B, I've got negative 8 plus a negative 5. How do I know it's negative? Well, when I look at the sign immediately to the left of my number, that's going to indicate whether or not it's positive or negative. If there's nothing there, it's positive. If there's a negative sign, then it is negative. So what this is saying is negative 8 plus a negative 5. So when the signs are the same, you add and keep the sign. So negative 8 plus a negative 5, you add and keep the sign. Negative 13 would be my answer. Think about going to the beach, okay? Everyone's been to the beach, hopefully, if not a playground where there's sand. You dig a hole in the sand, okay? The hole is your negative. And the pile of sand that you just took out is your positive. Well, if you see 8 holes when you first get to the beach and you're walking, and then you see another 5 holes, aren't there 13 holes in total? Of course there are, because you had holes with holes. When the signs are the same, you add and keep the sign. So I had negative 8 plus a negative 5. They're both the same sign. You add and keep the sign. Now, negative 2 minus 7. This is where people get confused, and this is where I'm telling you that it's really just always addition. Really what's happening here is you have a negative 2 plus a negative 7. Okay? The 2 is negative, the 7 is negative. They're being separated by this sign here, so there's an invisible plus that's separating those two. So it's really negative 2 plus a negative 7. It can be written like this, though, negative 2 minus 7. The signs are the same. You add and keep the sign. So negative 2 plus a negative 7 would be negative 9. C, 8 plus 19. The signs are the same. You add and keep the sign. 8 plus 19 is 27. Negative 6 minus 12. Again, this is really saying it's negative 6 plus a negative 12. So when the signs are the same, you add and keep the sign. So that would be negative 18. Okay. Next, number 2. When the signs are different or opposite, simply subtract as normal large number minus the small number and keep the sign of the largest absolute value. Okay? Pretty simple. So I got 8 minus 6. Please realize what this is really saying is 8 plus a negative 6. The sign of the 8, there's nothing there, so it's positive. The sign of the 6, there's a negative, so it's negative. When the signs are opposite, you subtract and keep the sign of the largest absolute value, so 8 minus 6 would be 2. 19 minus 27. When the signs are opposite, you subtract as normal and keep the sign of the largest absolute value. 27 minus 19 is 8, but there are more negatives than positives, so my answer is negative 8. For C, negative 11 plus 5. When the signs are opposite, you subtract and keep the sign of the largest absolute value. So negative 11 plus 5 would be negative 6. 13 minus 30. Well, 13 is positive, the 30 is negative. So when the signs are opposite, you subtract and keep the sign of the largest absolute value. So 30 minus 13 is 17, but I have more negatives than positives. The absolute value of negative 30 is larger than the absolute value of 13. So I have negative 17 as my answer. E, negative 16 plus 10. When the signs are opposite, I subtract as normal and keep the sign of the largest absolute value. So negative 16 plus 10 is going to be negative 6. Awesome. Okay, now we got a special case. And the special case states that when you're subtracting a negative number, the two negatives multiply together and become addition. Again, we're always adding really in the end. It's just a matter of if we're adding positive or negative integers. So for example A here, I have negative 6 minus a negative 15. Well, negative 6 minus a negative, this cancels out to a positive because a negative times a negative is a positive. So negative 6 plus 15 is really how this is read now. And when the signs are opposite, you subtract and keep the sign of the largest absolute value, which would equal 9. 8 minus a negative 3 is really 8 plus 3 because a negative times a negative is a positive. So 8 plus 3, the signs are the same. You add and keep the sign, 11. 12 minus a negative 9. This is really 12 plus 9, which is 21, because when the signs are the same, you add and keep the sign. I've got negative 7 minus a negative 7. So I've got negative 7 minus a negative. That becomes positive. When the signs are opposite, you subtract as normal and keep the sign of largest absolute value. 7 minus 7 is 0. 14 minus a negative 4. Well, I've really got 14. This minus a negative, that's a negative times a negative, which becomes a positive. 14 plus 4 equals 18, because when the signs are the same, you add and keep the sign. Now, there's a very important property that a lot of people just brush over, but I want to just take a few minutes and really hopefully help you understand this. For any non-zero number A, okay, there is one real number, negative A, called the additive inverse or opposite of that original A, as described below. This is called the inverse property of an additive inverse property, okay? And it basically states that when I have A plus a negative A, that really equals A minus A, which equals 0. Okay, when the signs are opposite, you subtract and keep the sign of the largest absolute value. When you add a number times its opposite, it will be 0. Now, how do you know if a number is opposite? Well, you literally just change the sign. So the original real number is 12. My opposite would be negative 12. If my original real number was 3/5, my additive inverse or opposite would be negative 3/5. If I have 2 3/8, okay, I can convert them to an improper fraction of 19/8, and the additive inverse or opposite would be negative 19/8. Or if I wanted to find the additive inverse or opposite of 2 3/8, that would equal negative 2 3/8. If I have an original number of negative, let's say 15, please note that the additive inverse of that would just be 15. The additive inverse is the opposite. And when a number is added to its additive inverse or opposite, the sum is 0. Rules for integer operations continue. Let's talk about multiplication and division. The rules for multiplication and division are identical, okay? They are the same. They work as follows. Sorry about that. So a negative times a negative is a positive. Also, a negative divided by a negative is a positive. For example, negative 3 times negative 2 is positive 6 because a negative times a negative is a positive. Example for division, negative 10 divided by negative 2 is positive 5 because a negative divided by a negative is a positive. A negative times a positive is a negative. And a negative divided by a positive is a negative. For example, negative 3 times 2 equals negative 6. Because a negative times a positive is a negative. And for division, negative 10 divided by positive 2 equals negative 5, because a negative divided by a positive is a negative. And last but not least, a positive times a positive is a positive, and a positive divided by a negative is a positive. So for example, positive 3 times positive 2 is positive 6. And for division, positive 10 divided by positive 2 is a positive 5. Those are the rules for multiplying and dividing integers. Similar to the additive inverse, we also have a multiplicative inverse or reciprocal property. And the multiplicative inverse states that for any non-zero number a, there is a real number 1 over a, called the multiplicative inverse or reciprocal of that original a, as described below. If I have a times 1 over a, okay, that's the same thing as saying 1 over a times a. That's going to equal 1. Why? Please remember there's an invisible 1 down here for a denominator, and a divided by a is 1. Anything divided by itself is 1. So when you multiply a number times its reciprocal, it's kind of like dividing each other by the same number. So a number times its reciprocal will always equal 1. Any number times its reciprocal will equal 1. Please note though, that a can never be negative. 0, I'm sorry. Please remember that a cannot equal 0. Because if there is a 0 in the denominator, the value is undefined. So there can never be a 0 in the denominator. So let's look to see how we find reciprocals, okay, or multiplicative inverses of real numbers. Well, if I have the value of 8, my multiplicative inverse will literally be 1/8. I do not have to change the sign. You change the sign to find the additive inverse. You just flip the original number or find its reciprocal to find the multiplicative inverse. So the multiplicative inverse of negative 3/5 would be negative 5/3. And now for my same example of 2 3/8, in this case, in order to find the multiplicative inverse, you have to convert the mixed number into an improper fraction. Okay? You have to. How do you do that? Well, remember, you take the denominator, multiply that times the whole number, which is 16, add that sum to the 3, which is 19 over the original denominator of 8. So if I did want to find the multiplicative inverse to 2 3/8, I'd have to convert it into an improper fraction of 19/8, and the multiplicative inverse or the reciprocal of 19/8 is 8/19. All right, so let's do a little bit of practice. Perform each indicated operation. Okay, let's do it. I've got 8 minus 12. Well, the signs are opposite. When the signs are opposite, you subtract and keep the sign of the largest absolute value. So negative 4 is the answer you should have written down. Negative 12 minus a negative 5. Well, when I have a minus a negative, this becomes plus, so this is really negative 12. Remember, negative times the negative 5 is plus 5. Signs are opposite. You're going to go ahead and subtract as normal and keep the sign of the largest absolute value. So this will be negative 7. I hope you answered that as well correctly. Negative 2 times 5. A negative times a positive is a negative, so that's negative 10. Negative 8 times negative 3. A negative times a negative is a positive, so that's positive 24. Negative 20 divided by 5. A negative divided by a positive is a negative, so that's negative 4. And last but not least, 48 divided by a negative, positive divided by a negative is also a negative, and that would be negative 3. I thank you so very much. I hope you learned a lot, and have a great day. Bye-bye now.